What if I told you that right now a telescope sitting over 1 million miles away from Earth is uncovering secrets that could change everything we know about the universe? In just the past few months, the James Webb Space Telescope has made discoveries that are blowing the minds of scientists across the globe. From uncovering mysterious black hole activity to detecting signs of potential life on a distant planet, each new revelation is more jaw-dropping than the last. This isn't just about pretty pictures of space, it's about rewriting the rules of science, challenging what we thought we knew, and opening up possibilities we never dared to imagine. If you're fascinated by the mysteries of the cosmos, if you've ever wondered whether we're truly alone, or if you just want to witness the cutting edge of scientific discovery, then stay with us. Because what you're about to learn might just change the way you see the universe forever. The James Webb Space Telescope, or JWST, has been described as a time machine, allowing us to peer into the furthest reaches of the universe and revealing secrets that were previously hidden in the dark. Since its launch, JWST has been making headlines with discoveries that could redefine our understanding of space. Today, we're going to explore 4 major revelations from JWST that have astonished scientists and raised exciting new questions about our universe. From an unusually active black hole in a nearby galaxy to an exoplanet that could hint at the possibility of life, each of these discoveries pushes the boundaries of what we thought was possible. And one thing is certain, there are still more mysteries to uncover, so let's dive in. The active black hole in Messier 106. To understand our first discovery, we need to travel 23 million light-years away to a galaxy called Messier 106. Most galaxies have a supermassive black hole at their center, but what JWST found at the heart of Messier 106 was extraordinary. Unlike the relatively quiet black hole at the center of our Milky Way, which occasionally sips on wisps of gas, the black hole in Messier 106 is actively feasting, consuming vast amounts of material almost constantly. When gas falls into a black hole, it heats up, reaching temperatures of millions of degrees, and emits intense radiation before crossing the point of no return, also known as the event horizon. This process causes the region around the black hole to glow brightly, creating what scientists refer to as an active galactic nucleus, or AGN. JWST's near-infrared camera, or NIRCam, allowed scientists to capture the AGN in stunning detail, showing a bright, glowing core that suggests immense energy output. This is significant because it tells us that the black hole isn't just sitting there, quietly consuming matter. It's actively altering its environment. But there's more. Messier 106 has an unusual feature: 2 extra, mysterious arms that extend from the center of the galaxy. Unlike the typical spiral arms, which are filled with stars, these are made up of hot gas and are visible only in radio and X-ray wavelengths. They aren't the kind of arms you would normally expect to see in a galaxy like this. So what's going on? It turns out these arms are likely formed by outflows from the black hole itself. As the black hole consumes matter, it also expels some of it at incredibly high speeds, creating these ghostly streams of hot gas. Imagine a fountain that sprays water outward as it draws water in. This process, called feedback, can have a dramatic impact on the galaxy. Scientists now believe that black holes are not just passive consumers of matter, they can also actively shape the galaxies they inhabit. By ejecting gas, they can prevent new stars from forming, effectively controlling the growth of their host galaxy. These insights are crucial because they challenge our previous understanding of black holes as simple cosmic vacuum cleaners. Instead, they act more like engines, driving the evolution of the galaxy. And if this is true for Messier 106, it raises the question, how many other galaxies might be experiencing similar processes hidden away in the dark, waiting for JWST to reveal them? The atmosphere of exoplanet K218b. Now let's leave Messier 106 and travel 120 light-years away to K218b, an exoplanet that has sparked enormous excitement in the scientific community. Why? Because it might just have the right conditions to support life. K218b is located in the habitable zone of its star, which means it's at just the right distance for liquid water to exist, a key ingredient for life as we know it. But until recently, we didn't know much about what its atmosphere was like. This is where JWST comes in. Using its advanced spectroscopic instruments, JWST was able to analyze the light passing through the atmosphere of K218b and detect the presence of specific molecules. The results were astounding. JWST found clear signs of methane and carbon dioxide, two carbon-based molecules that are closely associated with life on Earth. Even more intriguing, JWST detected these gases without finding large amounts of ammonia, which is what scientists would expect if these molecules were produced through non-biological means. So what does this mean? Could K218b have the right mix of conditions for life? Scientists think it might. The presence of these gases suggests that there could be complex chemical processes happening in the planet's atmosphere. And one possibility is that these processes are biological, but there's another detail that makes K218b even more fascinating. It's believed to be a Hycean world. Hycean planets are a new class of exoplanets with a hydrogen-rich atmosphere and potentially vast oceans underneath. These oceans could be kept warm by the planet's atmosphere, creating conditions that might support microbial life. The idea of Hycean worlds has only recently gained traction, but K218b is one of the best candidates we have for studying this type of environment. And while the presence of methane and carbon dioxide isn't definitive proof of life, it's an encouraging sign. Future observations will aim to gather more data, perhaps revealing other chemicals that could provide more clues. The possibility of finding life on a Hycean world is a thrilling prospect, but it also forces us to rethink where we should be looking for life. If life can thrive on a planet like K218b, it could be more common than we ever imagined, existing in environments very different from our own. Next, we shift our focus to a discovery that has turned our understanding of galaxy formation on its head. For decades, the prevailing theory was that galaxies grow from the inside out. Stars and gas accumulate around a dense central core, and over time, the galaxy expands outward. But recently, JWST observed something that doesn't quite fit this model, a galaxy that appears to be forming from the outside in. This early galaxy, observed in the distant reaches of the universe just a few 100 million years after the Big Bang, seems to be developing its outer regions first, gradually building inward. Scientists were stunned by this discovery because it challenges long-held assumptions about how galaxies grow. So, how could this happen? One theory is that the galaxy's environment played a key role. If this galaxy interacted with other galaxies, or if it was in a region of space with a lot of intergalactic gas, it might have been able to accumulate material on its outer edges before building up its core. Alternatively, this might have to do with the timing of star formation within the galaxy. Perhaps bursts of star formation occurred at different times, creating a layered structure. This kind of inside-out growth suggests that the universe in its early stages was more chaotic and diverse than we previously thought. Galaxies may not all follow the same path of development, but instead adapt to their specific environments in complex ways. This discovery raises more questions than it answers. If this galaxy is forming from the outside in, how many others are like it? Are there different types of galaxies we haven't even identified yet? And if so, what does that mean for our understanding of the universe's evolution? Finally, let's bring our focus back to something that has profound implications for understanding how our own solar system formed: winds from young star systems. When a star is born, it is surrounded by a disk of gas and dust, known as a protoplanetary disk. Over time, the material in this disk can come together to form planets, but JWST has uncovered a crucial element that plays a role in this process: disk winds. These winds are streams of gas that flow outward from the disk, carrying away excess material. They are essentially the star's way of regulating its environment, and they have a significant impact on planet formation. By clearing out gas and dust, these winds can prevent certain areas of the disk from accumulating too much material, thus influencing the size and type of planets that form. For example, if the winds are strong, they might prevent the formation of gas giants like Jupiter, leading to smaller, rocky planets instead. Thanks to JWST's ability to observe in the infrared, scientists can see through the dense clouds of gas and dust that surround young stars, providing a clear view of these winds in action. What they found is that disk winds can vary dramatically in strength and pattern, suggesting that they play a more complex role in shaping planetary systems than we previously thought. By studying these winds, scientists hope to learn more about how planets form and why some star systems end up with many planets, while others have only a few or none at all. But there's a more personal connection here too. By understanding how these winds operate, we can gain insights into how our own solar system came to be. Billions of years ago, similar processes would have been at work, influencing the formation of planets like Earth. It's a humbling thought to consider that the same forces we see shaping distant star systems today once played a role in the birth of our own world. Each of these discoveries underscores the transformative power of the James Webb Space Telescope. It's not just about looking further into space. It's about seeing things that were once invisible to us, uncovering new layers of complexity in the universe, and asking questions that we never thought to ask. The active black hole in Messier 106 reveals how these cosmic giants can shape entire galaxies, challenging our ideas about how galaxies grow and evolve. The atmospheric analysis of K218b provides hope that we might one day find life beyond Earth, showing that the conditions for life could be more common than we previously thought. The inside-out galaxy formation opens up new possibilities for how galaxies can develop, hinting at a universe that is more diverse and dynamic than we ever imagined. It suggests that in the chaotic early universe, galaxies might have formed through a range of processes, influenced by factors we are just beginning to understand. And the study of disk winds brings us closer to understanding not just how other planetary systems are born, but also how our own solar system emerged from a swirling cloud of gas and dust. The James Webb Space Telescope is proving to be a game-changer in the field of astronomy. Each of these discoveries challenges existing theories and opens up new avenues for research, but perhaps what is most exciting is that this is just the beginning. JWST is designed to operate for at least 10 years, and scientists have planned thousands of hours of observations. This means we are only scratching the surface of what this telescope can reveal. With every passing day, JWST is collecting more data, and it is very likely that more groundbreaking discoveries are just around the corner. So what can we expect in the future? For one, JWST will continue to explore exoplanets, focusing on those that could potentially host life. Its ability to analyze the chemical composition of distant atmospheres is a powerful tool that will help scientists narrow down the search for habitable worlds. By studying more planets like K218b, scientists hope to identify patterns that might suggest which types of planets are more likely to have the conditions necessary for life. In the coming years, JWST could provide the first concrete evidence of biological processes occurring on planets beyond our solar system. JWST will also continue to study black holes, not just in nearby galaxies like Messier 106, but across the universe. Black holes are enigmatic objects that challenge our understanding of physics, and there is still so much we don't know about them. By observing how black holes interact with their environments, JWST could help scientists answer key questions about how they grow, how they influence the formation of stars, and what role they play in the evolution of galaxies. The data from JWST could even provide insights into the mysterious nature of dark matter, the invisible substance that makes up a significant portion of the universe's mass, but has never been directly observed. The study of galaxy formation is another area where JWST will continue to make significant contributions. The telescope's ability to see in infrared light allows it to peer through dense clouds of gas and dust, revealing the processes that shape galaxies from their earliest stages. This capability is particularly valuable for studying the so-called cosmic dawn, the period when the first stars and galaxies formed. By examining this period, scientists hope to learn more about the conditions that led to the birth of the first stars and how these stars eventually came together to form the massive galaxies we see today. But what if JWST reveals something entirely unexpected? Throughout the history of astronomy, Some of the greatest discoveries have been the ones we didn't anticipate. When the Hubble Space Telescope was launched, no one expected it to find evidence of dark energy, the mysterious force driving the accelerated expansion of the universe. Yet that discovery revolutionized our understanding of the cosmos. JWST has the potential to do the same, uncovering phenomena that could fundamentally change our view of the universe. There's also the prospect of studying our own solar system in more detail. JWST will be used to observe the outer planets, the Kuiper Belt, and possibly even distant objects like comets and asteroids. These observations could shed light on the processes that shaped our solar system, offering clues about how it formed and evolved over billions of years. By comparing our solar system to others, scientists can gain a better understanding of what makes Earth unique. Or, conversely, what commonalities might suggest that life could exist elsewhere. What makes the James Webb Space Telescope so revolutionary is not just its ability to see further than ever before, but also its capacity to see in new ways. Unlike optical telescopes, which observe visible light, JWST is primarily an infrared telescope. This allows it to detect heat signatures, which means it can see through clouds of gas and dust that would otherwise block our view. This is why JWST can study protoplanetary disks and star-forming regions in such detail. It's also why it can look at the atmospheres of exoplanets and detect the faint chemical fingerprints that might indicate the presence of life. Moreover, the precision of JWST's instruments means that it can measure tiny variations in light, revealing details that were previously beyond our reach. This is how scientists were able to detect methane and carbon dioxide in the atmosphere of K2-18b. It's not just about seeing a distant planet. It's about understanding what that planet is made of, how it interacts with its star, and what that means for the possibility of life. The data that JWST collects will help scientists build more accurate models of planetary atmospheres, guiding future missions that could one day search for life directly. As we look to the future, one thing is clear. The James Webb Space Telescope is set to transform our understanding of the universe in ways we can't even predict. Its discoveries will inspire new theories, new missions, and a new generation of scientists who will continue to explore the mysteries of space. Every image, every piece of data is a piece of a larger puzzle, a puzzle that will help us answer some of the most profound questions humanity has ever asked. Are we alone in the universe? How did galaxies form and evolve? What role do black holes play in shaping the cosmos? These are questions that have captivated scientists and dreamers alike for centuries. And now, thanks to JWST, we are closer than ever to finding the answers. But as with all great explorations, every answer brings new questions, new mysteries to solve. The beauty of science is that it is a never-ending journey, and the James Webb Space Telescope is our guide on this incredible voyage through the stars. So the next time you look up at the night sky, remember that there is a telescope, 1 million miles from Earth, peering deeper into the universe than ever before. It is seeing things no human has ever seen, capturing images and data that are helping us unlock the secrets of the cosmos. And who knows, the next great discovery could be just one observation away. In conclusion, the James Webb Space Telescope has already changed our understanding of the universe in profound ways. Its observations of the active black hole in Messier 106 have revealed how these cosmic giants can influence their entire galaxies, challenging our understanding of galactic evolution. The detection of methane and carbon dioxide on K2-18b has provided a tantalizing hint that life might exist on planets very different from Earth, expanding our view of what makes a planet habitable. The discovery of an inside-out galaxy has forced scientists to rethink how galaxies grow, suggesting that the early universe was more diverse and dynamic than we ever imagined. And the study of disk winds has given us new insights into the process of planet formation, helping us understand how our own solar system came to be. But more than that, JWST has shown us that there is still so much we don't know. Every discovery is a reminder of the vastness of the universe and the complexity of the forces that shape it. It is a humbling, awe-inspiring thought, and it drives home the importance of exploration, of pushing the boundaries of what we know and daring to ask the big questions. The universe is a vast, mysterious place, and with the James Webb Space Telescope, we are beginning to see it in all its wonder and complexity. As we continue to explore the stars, let us remember that every answer is just the beginning of a new question, a new adventure. The James Webb Space Telescope is not just a tool for observing the universe, it is a testament to humanity's curiosity, our desire to explore, and our quest to understand. And with it, we are poised to embark on a new era of discovery, one that promises to reveal more about the universe and about ourselves than we ever thought possible.